Good evening everyone. This is our group Green Hen and today we are going to present our project Mechanoid 360. We have made a RC car which has an inbuilt hand claw. For more detailed explanation I would like to tell to Premanshu.
So, before understanding how our project works, we should have a knowledge about robotics. Robotics is a machine or some kind of robot that uses AI to perform any activity. AI is artificial intelligence, and artificial intelligence is when something like a machine or a robot uses complex mathematical orders and complex algorithm to perform any activities like the robotic arm over here.
So in this project we have used many complex and simple things. For example, this pipe and then water pump, circuit board, batteries, jumping wires, capacitors, LEDs, breadboard, touch sensors, buzzer, evaporator, infrared, topper, voltage booster, motor, shaft, switch, gear and belt, etc.
Now we see this video in which we can see the performance of the robotic arm. So this is a 6-axis robotic arm. 6-axis means 6 degrees of freedom, which is 6 dov. So degrees of freedom means a robotic arm's movement in one direction or an angle. So if I move my hand like this, my forearm is moving back and forth. So it means it is moving in 1 degree of freedom. So if I twist my ankle like this is another movement in some angles. So it is 2 degrees of freedom. If we combine 1 and 2, there will be 6-axis hand, 2-axis hand. So the robotic arm of our project is a 6-axis robotic arm. So we can see an industrial 6-axis robotic arm working to organize these cardboard boxes as per the sizes. So the movement will be something like this. But this is a 6-axis robotic arm, and the robotic arm in our project is a 2-axis robotic arm, because this is just a prototype. The final product will be more bigger and more advanced, fully functionable and long ranged RC car with robotic arm on top of it. Now we explain all the parts as per Dwiti said.
First we have pipe. So this is a pipe which will throw the water, and to throw the water we need a tiny water pump.
Then we have this circuit board. In the circuit board we can attach many components and solder it, from which we can permanently use the circuit board as something for connections and etc. In a large scale. Then we have the most important thing, our power source. For our power source we are using some 9 volt and 4.8 volt batteries.
Then next we have jumper wires from male to male, female to male, and female to female. These are the 3 kinds of jumping wire. So jumping wire are nothing. These are just wires which have a pin in front of it. It can be a female pin with no sticks, or a male pin with a stick on the top. This is attached in the circuit boards like breadboard, Arduino Uno, etc. Then we have capacitors. So These are two capacitors with different capacity of electricity. Capacitor is a small device which contains electricity when it is powered up, and it can store the electricity for a short period of time. For example, if you are working on the prototype or some wires, like we were working on this hand, so imagine that your current is gone. So this capacitor will keep the current for some time, like 1 to 2 minutes or less or more, and we can use the electricity to save our products.
Then we have the most simplest and the most common thing, LEDs. So the LEDs which we are using in this robot is some colorful LEDs like green, red, yellow, blue, white, and etc. and RGB LED.
Then we have breadboard. Breadboard is a temporary connection circuit. So this requires jumper wire to connect it, or we can connect it with the normal wires. So in this back we have metal strips which are connected to these pin holes. From one metal strip is from here to here, means like horizontally connected in the center too. But in the power, like here you can see blue and red strip which stand for negative and positive. Here the pins are vertically connected, like from here to one point here and another point from here to here. So these metal strips help us to transfer the electricity and use it for a temporary circuit for testing or practical.
Then we have a small tiny component which is known as touch sensor. So touch sensor basically used in project from which we can use it as a switch or some kind of sensor, in which if we touch the surface of the circuit board, it will detect our touch. The touch cannot only be detected by our hands, it can also detect objects like plastic, metal, and etc. Then we have a buzzer. Buzzer is a small tiny component which converts electrical energy into sound waves. It happens with the vibration of a plate inside it. It sounds like this.
Sounds familiar, right? It's also inside your inverters, and it's played when the power is overloaded or gone. Then we have evaporators or vaporizer. These are some devices which converts water into water vapor instantly, and the water vapor are easily available. So we are using this in our project as a decorative item, as we don't like electric cars, so we are just using it like a exhaust.
Then we have this tiny component which is known as a flame sensor. Flame sensor works when there is infrared light in front of it. So this black LED kind of thing detects infrared light, from which we can detect fire, because fire generates infrared light. So from this component we can detect the fire and can throw water automatically from this water pump, as Briti showed at the starting.
Then we have the topper. So topper is used in the servo motor hand. So here, like you see in the hand is properly functionable and movable. So to connect the hand with the servo motor, we use this topper. Some people also call this a servo hand, as this works as the hand of the servo motor, and this is a aluminium servo hand, so it has a very high strength.
Then we have a voltage upgrader. Voltage upgrader is something which can convert low voltage into high voltage. So if we give 3, 4 or 5 volts as input, it can give 12, 50, even 60. It can convert the less amount of volt into high voltage current.
Then we have this master, also known as 775 gear motor. So this can go up to 1000 RPM, which is pretty fast for our car.
Then we have these two rods which we are using as a shaft. So at the end of this rod, four wheels will be connected, and we can attach this rod and spin both the wheels at a time with only one motor by attaching gears and gear belt. Then we have all these toggle switches. So what toggle switches are? They are a special type of switch which can move a motor back and forth. With a press of this switch point, we can turn the motor's direction. Then we have
the gear and belt. So like we have connected the motor with the shaft to show. Like here you can see whenever the gear will spin, the shaft will spin as we have connected with the gear and belt. So that's it for our today's. So
now let's
do the practical.
So basically you can see,
so
there is a trapezium rod at the center which can move this whole claw, the gantry, up and down. Now then we have this claw at the top which can open and close to hold and hold. Sorry, we don't have proper grips. We will adjust it. So it can hold up to 750 grams because of the powerful MG, which stands for metal gear servo motor, which has an input of 6 volt, which is a lot powerful if you compare it as the size. So it can hold this small battery which weighs almost 20 to 40 grams, but the maximum weight holding capacity is 750 grams.
So here you can see the connection. We have attached it with the Arduino Uno over here. And breadboards and other things. So we will attach more things and more components in this car, but the problem is we have less time and less supplies. In future we will definitely try to complete this project and show it to you. So this was for our project, and this is our group Green Help.
Now do you have a question? How does it works from a remote?
So this is not a remote, this is a receiver and transmitter. This is a transmitter and receiver is over here. This one.
So what happens when you move any of these switches and potentiometers? It sends.
We will attach more things and more components in this car, but the problem is we have less time and less supplies. In future we will definitely try to complete this project and show it to you. So this was for our project, and this is our group Green Help.
Now do you have a question? How does it works from a remote?
So this is not a remote, this is a receiver and transmitter. This is a transmitter and receiver is over here. This one.
So what happens when you move any of these switches and potentiometers? It sends a signal to the receiver which is in gigahertz. So this is 2.4 gigahertz of signal, which can have a range up to 1 kilometer. So hope you liked all our connections and explanation. We would like to say you thank you.
So this is our final products, and this is for the base and hand. So this is not for the top. The top part is also in progress. Hope you like our video, and we will try to complete our project in the future. Thank you.